Good afternoon, everybody. Welcome to class today. First off today, I just want to take a moment and just thank you for watching. Whether you're watching with me live now or watching with me recorded later on, thank you for taking the time and watching and being engaged in the material. So before we get started today, I just wanted to do a little bit of housekeeping because this is an odd day and time for this live stream. Just kind of fill you in on why we're doing this. If you were doing on-campus classes tomorrow at Cleveland Community College, they would be canceled. But since we're online, we kind of got to keep pushing through. On campus tomorrow, they're doing some meetings for faculty and staff that we'll be involved in all day long. For various reasons. Primarily focused on professional development and like improving the quality of service that we bring to you here at Cleveland Community College. That's a goal that we have, is that we want to make sure that we are providing you all as students the best service that we possibly can. So if you feel like there's anything that we can do to help, please feel free to reach out. As always. But that's why we're no live streams tomorrow. If you are also in my Web 115 class, the introduction to web markup and scripting, in lieu of a live stream for that class, I will be posting some pre-recorded material tomorrow, and I'll also be extending my office hours on Wednesday. So anybody in this class can take advantage of that. Or the Web 115 class. Any of you all can take advantage of that as well. I'll be extending my office hours to start at 9 a.m. on Wednesday morning instead of 11:15 a.m. like normal. So longer office hours, in addition to some other material at some different times, to try to make up for breaking our routine this week. I don't like having to break routine for this kind of stuff. I only do it when I absolutely have to. And I especially, don't really like posting pre-recorded material in lieu of a live stream, because I think the live stream material should be for you all, right? Like, this is your class, and I think you should have something that is specifically for you. right? So posting pre-recorded material that was done for someone else initially, I'm kind of, I don't really like doing that, but sometimes it's, it's what we have to do based on the time schedules that we have and all that kind of stuff. Trying to make everybody, trying to do the best I can to help you all kind of stay on your schedule, stay on your routine by giving you the information as close to possible. If we can't do it on the day that we're normally supposed to do it, we need to do it before. That way you can kind of stay on your routine, even if I have to break mine. Because you can always go back and watch this stuff later. So I think that's enough about that. We got a lot to talk about today when it comes to talking about lists. And in terms of lists, we're going to be talking about lists in reference to several other things that we've kind of talked about previously. We can look at the idea of lists in a frame of reference with variables. We can look at lists in a frame of reference with string manipulation that we looked at last week. But as we get started with lists here, one of the big things that we need to kind of examine is this term lists. Because the term list is specific to Python. In Python, we call them lists. In other programming languages, we call them something different. So if you are moving from this class into something else that does programming in a different language, it might not call them a list. Instead, it might call them an array. So just right off the bat, and I know I have a slide that says pretty much the same thing as well. Just right off the bat, I want to get this bit of terminology out there. That when we're thinking about lists in Python, we're thinking about arrays in basically any other programming language, and I'll probably use the terms interchangeably. I'll probably say lists or arrays. I'll typically, I'll catch myself in the Python class here saying array more times than not, even though I know Python calls them a list. Just, do your best to put up with me, if you would, please. Because really, in any other programming language, they are arrays. Just, we want to be terminologically correct, if at all possible. However, this one's a little bit tough for me. So just what exactly is a list? Right, so a list is a sequential collection of values. So a list is a data structure. It is a sequential collection of values that we put into a structure. And each value has a location, an index location. So this should start to give you flashbacks to last week, right? To when last week we were talking about index locations in terms of the string values or the character index list location values in a string, right? If you'll remember back to last week, we looked at strings. We said something like, oh, we got the word tree. If we want to iterate through this word tree, or we want to refer to a specific character in our word tree, we can refer to this via its index location, 0, 1, 2, 3. So now we're bringing back the idea of index locations back for another week. But instead of talking about characters in a string, we're talking about data values inside of a collection of data values, or some kind of value inside of a list. So when we're talking about our index locations for our list, they work the exact same as our index location values did for our string last week. The only thing that makes them different is what they number. Right, because when we're looking at a string, we're looking at a sequence of characters within a string. When we're looking at our list or array, if you will, we're looking at a sequence of values inside of a data structure. So we're still numbering things sequentially using index locations. The only difference is what exactly we're numbering sequentially here. And one of the ways that I like to kind of think of this, if we want to think of it in terms of a lot of the other stuff that we think about, is I kind of like to think of this in terms of the way that we think about variables. Right? If you'll remember back when we first started talking about variables, we said a variable is a container. And we can take data and put it inside of that container. Well, now what we have here with a list is we have this structure that gives us a collection of data values. So we can almost think of a list or array as a variable of variables, or a container of containers. Right? So we have one big container in which we can refer to other data values that are in smaller containers based on their index location. So if I have a list that I'm calling trees, for example, I can have multiple containers in my list called trees, and I can have oak, birch, pear, apple, what have you. And so each of these go into one of these subcontainers inside of my larger data structure. And I can refer to them via their index location. So I have trees 0, trees 1, trees 2, and trees 3. So with this index location and with this data structure with our list, we're seeing the exact same sort of structure that we were seeing when we were talking about index locations last week with strings and string manipulation. We're just extending it into this new data structure. Just like with strings, our indexes range from 0 to 1 less than the length of the list, which is what I mean by n minus 1 here. And from -1 to -n when we're going backwards, the other way. Now, one of the interesting things about lists in Python that make them different from lists or arrays, rather, in other programming languages, is that lists in Python are heterogeneous. Which is really kind of, it's kind of neat. I haven't really found a ton of practicality, just in general stuff that we do for at the basic level here for utilizing heterogeneous lists. But the idea that we can use heterogeneous lists is an important one within Python, because it's something that we don't have in other programming languages. For example, in Java, arrays are homogeneous. If I have an integer array, I have to declare it as an integer array, and I can only put integers in it. If I have a string array, I have to declare it as a string array, and I can only put strings in it, and so on and so forth, depending on the data type of said array. And that's what it is for Java. But when I look at Python, with lists being heterogeneous, I can put all sorts of different data types inside of one list. I can put an integer, I can put a string, I can put a Boolean value, all inside of the same list. Which is really neat. You might think of an application for that, especially as you're thinking about ideas for your final project. You might think of a good application to utilize, to make good use of these heterogeneous lists. And we actually have an example of a heterogeneous list on the next page as we talk about list syntax. So what we have here is with our first bullet point is a declaration of a list. After the comma forward here is a declaration of a list. You can see that we have, a name that's like a variable name here, and then we're setting it equal to a sequence of values. Now, in this case, we're setting the sequence of values equal to, or this sequence of values that we're setting equal to this list name, we're putting them in square brackets. And these square brackets denote that this is a list. And you see in this example here, my list equals 3a true. We have a number, an integer, a string, and a Boolean value, all in this same list, which means that what we have here is a heterogeneous list. This is a completely valid list in Python. I can use this. No problem. I can even put a list inside of a list. I can put as many lists inside of a list as I want to, and just nest them as deep into one another as possible. Now, it's typically not going to be useful, right? But you could come up with an idea, like just sitting here thinking about it. One of the things that you could do is you could use this for data storage. When we get into actual data storage a little bit later on, we'll work with some other stuff that'll make it more, make this kind of working with data storage a little more obsolete. But if I wanted to put like a name, a number, and whether or not they were a current employee into a database or into a list, I could put that in for each new person as a new sublist, which could be interesting, could be an approach to it. And when we refer to a list, we can refer to a list by its whole name, which in this case would be my list. And if we wanted to refer to, say, the A here, we would refer to it by its index location. So that would be my list index 1. As it's 0, 1, 2. Now, what makes lists, when it comes to the index locations inside of lists, different than using index locations in strings and traversing through strings? And what brings us back even more to this idea of having these sort of nested containers is this idea that lists are mutable. Remember, one of the things that we said last week was that strings are immutable. Meaning that if we refer to an index location of a character in a string, we can't directly change it, not unless we use the replace function. But even when we use the replace function, that's making a copy in memory and making something new. Our lists are mutable, meaning that we can change things in place. So if we start with a list like this, we want to change something in it, all we have to do is we can just focus on a specific index location and reassign the value in that index location, just like we were reassigning a variable. So let's check that out in a REPL, shall we? Let's start with a little bit of proof of concept stuff, and then a little later on we'll do a bit of a longer program. But what I want to do here first is just kind of look at the mutability of lists, right? And I want to look at some of the other stuff that happens when we do certain actions to a list. Right, so let's start off with our shebang here. And since this is just going to be like a little proof of concept, I'm just going to do everything behind the main gate without any additional functions. So we'll add our main gate in here like this. So what we can do here is we can declare ourselves a list. So let's create a list. And let's make that trees list again. So we'll create a trees list and we'll set it equal to oak, birch, pine, we'll put a 7 in here for no real reason. And what's another good tree? Let's just go for that pear. You know what? Dogwood tree. We're in North Carolina. Why not? Dogwood tree. And we'll replace our 7 there with our pear tree here in just a few moments. So now we have this list that we have declared. We've created our bucket here for our list. We put a bunch of smaller buckets inside of our bigger bucket that contain each of these data values. So one of the interesting things that I can do here is I can print this list. I can print it directly. Print trees. And that's going to give me my list just formatted as a list. Now we can do some other stuff with this, right? Like the whole enhanced for loop that we talked about last week. That works here too. So if I wanted to say something like for tree in trees, print tree. That gives it to me as a bit of a different type of formatting display here, which is nicer, better. But we'll hold off on that for just a moment. Let's so we saw that. Let's replace that 7. Let's replace it with something else. Because 7 is not a tree, 7's a number. So we want to redo that number, right? So let's first look at our string, or our list rather, to find out what index location that is in. So if we look at this, we can number our values if we need to. 0, 1, 2, 3, 4. So we see that our 7's in index location 3. And so now I can take in my list, which is trees, at index location 3, I will set that equal to pear. A nice pear tree. So now if I print trees, we'll see that Instead of 7, pair. So again, unlike when we were dealing with strings last time, where we couldn't change a value in place, with our lists, we can change a value in place, which is ideal. It's what we want, especially with lists. Because this might be a situation where we're adding something, or we're changing something, or we're removing something from the list. We're utilizing these buckets to reassign the data, just like we would with variables. And so it's this type of stuff that helps us out in that regard. Now, one of the interesting things here that we can look at is that a lot of the same stuff that we were doing with our strings still applies to our lists. Just now we can do more. For example, the length function. This is one thing we looked at last week to get the length of a word. We can also use it to get the length of our list. It's the exact same thing as with our string. Right? So if we head back to our REPL, and we print the length of our list, we should expect to get 1, 2, 3, 4, 5. 5. And so that works exactly the same. So what we've seen here now, as we're accessing these different elements in our string, or in our list rather, I'm getting a little bit ahead of myself because I was going to say, we can access all of these the same way that we can access elements in our string. So we're just going through that index location. So we've seen us access elements via the index location. We've seen us access elements via a for loop. The for in loop that we looked at there. All of that still works. So that's how we use a list. Well, how do we create a list? Well, we've already seen one way that we create a list is just by hard coding the list. Another way that we can create a list, if we want to create a list that's all a bunch of the same thing, is that we can use our replication operator, which is pretty neat. So I can have my list here, set it equal to whatever I want my list to be. Use my replication operator to multiply it by how many times I want that list repeated. And it'll give me a repeated list for that amount of times. So in that case, it's a little hard to kind of wrap your brain around. But I like to do it this way just to show people what that really means. So we'll create a list called 1_2_3. And we'll set that equal to a list of 1, 2, 3. But then we'll use our replication operator and multiply that 10 times. So what we should see here is a list is that we've ended up with a list of 30 elements. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, so on and so forth. So let's print this list in addition to our other lists here and see what we've ended up with. Just like that. And so this does have some use. You know, if you want to start with a list that is a specific size, but you don't necessarily know what you're going to put in it, you can utilize this replication method. There are a few neat things here that you could utilize this for. Now I'm going to hold on to this list here, and I'm going to use it a little bit when we talk about list comprehensions, because we're going to need to talk about list comprehensions, because list comprehensions are super important. But another thing that I wanted to talk about before I get there is using the split method on a string. And this is something that you'll need a bunch of times. This split method is one of the most valuable things to me when I'm just making quick programs. I love this split method. So let's check out this split method really quickly. So with the split method, I can create a list based on user input. And I can determine what I split it on. So for example, let's say I want to take a sentence and split it on words and get a list of all the words that are in a sentence. Well, we'll create a variable here that will be our list. We'll call it a sentence, and we'll set it equal to input, enter a sentence, and then we'll add dot split, open and close parentheses on the end of that. I love this split method. And so what this will do, by default, it separates on spaces. So let's add a little print sentence down here. So what this will do is it'll take the user input, split it at every space, and create a new element in a list called sentence for each word in that list. So let's run this and see what happens. Hello, world, how are you? And you can see down here at the last one, that is my split sentence. You'll see there's no spaces in there. It's just hello, world, how are you as separate words. And so if we're utilizing this and we're utilizing things like len, we can actually manipulate lists dynamically, have them dynamically created and dynamically manipulated based on what our user inputs. Now, another thing that we could do here with our split function is decide what character we split on. Maybe we don't want to split on spaces. Maybe we want to split on something like a dash. So maybe I want to create a variable called date converter and give that an input of enter date mm-dd-yyyy dot split. So the expectation here is that the user is going to enter a date in this format that we see here in our input text line. So there's no spaces in there. So there's nothing to split on based on what's default. But we can choose what we want to split on. So we could split on dashes. So let's comment out some of this so we can just not worry about it for a little while. I'll hold on to this. We'll want to hold on to all this so you can play with it later when you get the demo files. But we'll print date converter. Enter date, month, dash day, dash year. So what is today? Today is 03-15-2021. And so we get 3 strings, because remember, everything from an input comes back as a string of 03-15-2021. Now, how can we do something with this? Well, you've got a little lab that works with this in the next module when we're talking about dictionaries, right? But for the time being, let's do a really simplified version of this. We'll print date dash converter. Maybe we want to do it European style, right? So we'll do it European style, which is day first, month second, year last. And maybe we only want to do 2 characters in the year. Right, so it's date underscore converter. We'll start with the one at index location 1, which will be the day. We'll concatenate that with a dash. We'll concatenate that with date underscore converter at index location 0. And we'll concatenate that with a dash. And we'll concatenate that with date converter 2. And we'll grab the last 2 from that. So that's going to be 2 to the end of that string slice there. Just to do something a little bit interesting with that while we're at it. So month, day, year. So let's do today. That's 03-15-2021. So we'll get day, month, 2-number year, 15-03-21, European style. Very cultured. Right, so we're able to take them out, we're able to swap them around, we're able to do things with them. Very critical, right? And that's going to give you kind of a leg up on one of the labs that you have in the next module. Now let's talk about list comprehensions for a minute, because a list comprehension is super important, because everything that you get, right, in an input function like that is going to be a string. So list comprehensions really help us out in situations like that. Right, so we can kind of look at that way. You know, when we get something in as a string, one of the best things that we can use a list comprehension for is to iterate through a list and typecast everything from string to int. But we can also use them for all sorts of other purposes. A list comprehension really is just a way that gives us a concise way to create lists. So what we have is a set of brackets that contains an expression followed by a for clause and then 0 or more clauses for it. So essentially, you know, we can say like 2 times x for x in list. Int x for x in list. And what we get here is we get a new list based on the values of our old list. Which is pretty cool. So let's check that out with what we're doing here. So I've got my date converter here, and we can see it here. Now that's effectively, well, it won't, right? It won't break this because date converter will still be, because we're going to be making a new variable out of this. So we'll have our date converter, and we'll create a new date underscore converter underscore I for integers. And we'll set that equal to int x for x in date converter. So that'll automatically go through everything in date converter in this list after we make it and convert it from a string, as it is now, typecast it to an integer. So you can see here, we have these values here. We can see they're in quotes because they're strings. But now if we run that through our list comprehension, created list here, we can run that. We can create a new list, 03-15-2021. And now when we see that list here, one, it's not 03, it's just 3. And there aren't strings. They aren't strings. There's no quotes around them. So we have numbers here that we can do math with if we want to. So that's some really valid, really great stuff there. So what I want to do is I want to kind of run through some other stuff and then do some examples in a bigger program. So I just kind of want to run through a few slides here really quickly and then try to do a big program here at the end to kind of wrap things up. One is the ways that we can add things to a list. We can append to a list, or we can also concatenate to a list. We can use both to add elements to an existing list. However, the concatenate operator in this instance can only be used to join two lists together. So you can't join a list and another data type. You can only join two lists together. So if I have list A, list B, I can put them together with a plus sign, get list C, which is everything from both lists A and lists B. However, if I use my append function, I can take a new element of data and add it to an existing list to make that existing list longer. And this is what we use more often than not, is that append function. Because that allows us to, maybe take an input from a user, do all sorts of stuff to be able to make our list longer. And it just keeps adding and adding and adding to the end of our list as we append more and more and more things. And so we call this list accumulation. So as we can create a loop where we add more values to a list. Essentially, we have a fancy name for that, which is list accumulation. And then we can output a list. We've seen the methods for outputting a list. We've printed just the list in and of itself. And we've also, used the enhanced for loop that we used last week to print out each character in our string. So you know what? We don't have to spend any time on that because we've already seen it today. In addition to our append method, we also have a sort, a reverse, an index, and a count. And these are all pretty interesting. Append, we add to a list. Sort, we can sort a list of items in place. If we're using the sort function, items must be comparable, which means our list needs to be homogeneous instead of heterogeneous. Reverse reverses our list of items in place. We can get an index location of a particular occurrence of a data value inside of our list, and we can count the number of times a particular data value occurs in a list. And these are methods. Now with methods, these all change the original list. Right? So our methods change our original list. And with our lists, we have two different sets of things that we use here. We have our methods and we have our functions. And our methods, which are these here, pause the video, read everything, they change the original list. Because remember, lists are mutable, so we can change the original list. But we also have functions that will allow us to create a new, it creates an object and put it into a new thing. So if we want to retain the original list as well as a new list, we need to use the functions instead of the methods. So here are a list of functions. Min gives you the smallest element in the list. And again, items must be comparable. Anything where we're looking for smallest, largest, where we're trying to sort, anything where we're comparing items within a list, it needs to be a homogeneous list. Because you can kind of think about that like, well, what's bigger, apple or 8? What's larger? Notebook or 7? Right? Like you can't compare those, right? So we have to have comparable data typed elements inside of our list in order to get that stuff. Sum list returns the arithmetic total of all the items in the list. If you're returning a sum, everything in that list has to be math. Math related. It has to all be integers or floats. Sorted list gives us a new copy of a list in ascending order. And then reverse list gives us the reverse order of the list. And with the reversed here, you actually have to use a list typecast to get the list. So you have to reversed and also use a list and put it in quotes of your existing list. To do this, this is a more complicated one, so I'll do this one really quickly in our little demo that we have going here. So if I want to go trees reversed, trees underscore reversed. If I do trees, or rather reversed trees here, and print that out to our console. Print trees reversed. You'll see what we get. That doesn't matter because I got rid of all the output. We get list reverse iterator object at, we get this data. That's not what we want, right? We have to typecast that. Let me remember to comment out those lines this time. So we have to typecast that as a list to get that to be something that is workable. Then it works just fine. And you see it's in the reverse order. It's not in reverse sorted order. It's just in reversed order that we have it here. So it's oak, birch, pine, pear, dogwood, dogwood, pear, pine, birch, oak, right? If we wanted to sort that, we could also do a trees sorted. Trees sorted equals sorted trees. And then instead of trees, we do trees sorted. And then from here, we'll have a list of trees in reverse alphabetic order. Pretty useful, pretty useful. So that'll be the end of our demo here. We'll rename this CIS 115 OL Sp21 lists proof of concept. We'll create ourselves a new REPL for a big program here. And it'll be our grocery list program. And so this will be taking some of the things that we talked about in the slides there and applying it. So you can have a look at everything in action. So what I'm going to want to do is I'm going to want to check this. I'm going to want to essentially create a grocery list program here to where you can add things to your grocery list. And I want you to be able to, if you enter it twice, or if it's already on the list, I want you to have the option to remove it. So you can, you can say no and maybe made a mistake and avoid it. Or remove the item from the list that you entered twice. So this would just be a little grocery list program here. So let's get to this, and since we're running pretty late, I'm just going to run through this pretty quickly. We'll start with our shebang, which is going to be hash bang. Python 3. And what we're going to do here is we're going to start off by creating ourselves an empty list. And this will be the list that we use in all of our functions that we're sending to and we're reading from. We'll kind of put it at a global level here so that we can have a place for things to go. So now we have this list that's been established that is at the global level that we can put things in, that we can read things from. And so we don't have anything in it yet because we don't have any groceries on the list yet. We're going to take that from our user. And so what we'll do is we'll take an input in our behind our main gate. But let's start off by doing a grocery list function that will give us the option to add or remove, right? So if it's in the list, it'll ask us if we want to remove it. If it's not in the list, it'll add it to the list. Makes sense. So we'll create a function, def grocery underscore list, and we'll give it an argument of item. Now the first thing that we're going to want to do is we're going to want to check to see if the item's already in the list. So we're going to write an if statement here. We're going to write that conditional if item in list, or if item in groceries. Well, if it's in groceries, we're going to create a variable. We're going to call it remove. And we're going to set that value to the input of already on list, would you like to remove y/n? If remove.lower, we'll do some data normalization here. So if they enter a uppercase y or if they enter a lowercase y, we'll make sure it's a lowercase y just so we can check it against one letter, which is a lowercase y. We will groceries dot remove item. Just like that. We really don't need an if. We really don't need an else statement to go with this particular if statement. We can just let it go. You know, it's just a little error correction. Go back around. It's fine. However, we do need an else statement to go with if item in groceries. We need to know if it's not in groceries. What do we do? So we'll write a little else. We'll print out item added, and we can really do this in either order. We could add it to the list first, or we could print out the message first. Either way, it's just fine. But we will groceries dot append item. Very good. Now from here, let's ask our user if they want to print their list. So we'll create a variable here called print underscore list, and we'll set that equal to the input of would you like to see your list y/n. Same deal here. We're going to check to see if print underscore list equals or print underscore list dot lower. We'll do that same normalization here. We don't want to do anything different, right? Equals y. Well, we're going to create another function for printing our list. So we're going to create a list called create a list printing function called list printer. So that's list underscore printer. And you know, I'm kind of in the future. I know what I want it to, you know, I've already written this. I know what I want it to be. So it'll have a argument of your list. Else, we're going to print thank you, just because we're real appreciative. Let's add an extra line break in there. And so that's all we need to add and remove groceries from our list. We've got this function here now that can do that for us. And you know, remember, if you're, you know, especially if you're watching this recorded, you can pause the video, you can rewind, you can go back, you can do all that stuff, right? That's the great part about videos. So now let's write this list printer function. So that's list underscore printer. And it's going to have we need to add our def keyword here, def list underscore printer with the argument of message. And I got a little fancy with this when I did it, so we'll just do it that way here as well. So that'll be groceries.sort. We'll use that sort method to sort our list in place to get everything in alphabetic order. We will print our message. And then we'll say for let's do for grocery in groceries. we will print, and let's do a formatted print statement here. So that's print F, open quote. Let's do something fun. Let's do Windows key, semicolon, to get our emoji keyboard. Find a neat little symbol here. How about this this chicken leg? Curly braces, grocery, close the quote. And so when we do this print with this F here, that's a formatted print. That's a little bit different. And when we do that, we don't have to concatenate variables. We can do them in curly braces like we've done here. So it's just a slightly different way of doing the things that we've done before. If you don't like doing it this way, you can always do it the other way, where we don't have that F there and we just concatenate our grocery variable with whatever we choose to be the bullet for our list. But that is essentially that. So from here, what I can do is at our main gate, if name we'll add a little while loop here, while true. We'll create a little start program variable here. And we'll ask our user input, would you like to add to your grocery list? Question y/n. If start program dot lower is y, we will grocery list we'll create a variable called item. We'll set that equal to input, enter item, and then we'll pass that in here. Grocery list item. Else, we'll execute our list printer with the message of your final list. And from here, we'll also have to break this loop. So we'll add a break term here to finish it up. And that's our program. Fairly simple. So let's check it out. Would I like to add to my list? Yes, let's add to my list. Let's enter item, apples. Item added. Would I like to see my list? Yes, I would. Apples. There it is. Would I like to add to my grocery list? Sure. Let's add some grapes. Item added. Yeah, let me see my list. Apples and grapes. That's great. Let me add something else to my list. Sure, let me add bananas this time. Now, if we weren't sorting the list, it would be, just in whatever order we entered it in, apples, grapes, bananas. But since we are sorting the list, we get, oh, I forgot my parentheses there. Now that'll work. But we'll just move right along for the sake of time because we've already blown past our hour. When we say no here, we get our final list and we are done. Aside from the little typo there, with our sort function with groceries, everything works perfectly, exactly the way that we'd want it to work. Nice, fun little grocery list program. And with that being said, we will call it there for today. I'll hang out in the chat for just a moment, just in case anybody who is here with me has any questions that they want to add. Otherwise, we will see you next time. Thank you for watching.